Hi everyone, today we are going to continue the 9th class toppers JEE NEET Foundation Chemistry Behavior of Gases. Already previous we have done with 2 sessions, single correct answer type, multi correct answer type and comprehensive passage type questions. So today we are going to start our session with matrix matching type questions. Okay, let's start. Let us see the first question. First matrix matching here. See, they have given 2 columns, column 1 and column 2. So, they have given this side the laws and this side the mathematical expressions for the respective laws. So, we have to match the mathematical expression correctly to this matching, right? Okay, let's see. The first one is Boyle's law. Second one is Charles' law, Dalton's law and Graham's law. So, this side they have given in the column 1 different types of the laws and in column 2 they have given different types of mathematical expressions. So, we have to match the correct mathematical expression to the correct law. Okay, let us see. First one is Boyle's law. We know Boyle's law already in the previous sessions we have discussed, and one more time I will explain. Boyle's law is at constant temperature, pressure is inversely proportional to its volume. So, pressure and volume relation is Boyle's law. If you comes to the column 2, in first option there is no pressure and volume terms, pressure and volume, pressure and volume. So, in A, B, C no pressure and volume terms, and in D P1 V1 equal to P2 V2, and in the E option it is total pressure equal to P1 plus P2 plus P3. Actually, what is Graham's law, what is Boyle's law? P proportional to 1 by V, PV equal to constant. So, P1 V1 equal to P2 V2. So, the correct option for Boyle's law is D. Boyle's law is P1 V1 equal to P2 V2. Now comes to the next one, Charles' law. We know the Charles' law statement. Charles' law is at constant pressure, by keeping the pressure constant, volume is directly proportional to temperature. Then V by T will be constant, then V1 by T1 equal to V2 by T2. This is the expression for Charles' law. Let's see this expression here. V proportional to is also Charles' law. V1 by V2, see this V2 comes here, then T1 comes here, then it will be V1 by V2 equal to T1 by T2. So, both A and B belongs to Charles' law only. So, I will go with both A and B options for Charles' law. Comes to the C, D, E options. C is the, R is here rate of diffusion, M is molecular weight. So, that is not related to Charles' law, and D option is related to Boyle's law, and E option PT means total pressure, that is okay, but in Charles' law we will keep pressure only the constant, then E option will not be. So, I will go with A and B. Next come to the Dalton's law. What is Dalton's law? Dalton's law of partial pressures, we can say. Already in previous session we discussed Dalton's law of partial pressure. Dalton's law of partial pressure is the total pressure exerted by the container equal to sum of its partial pressures, right? So, E option is correct for Dalton's law. Come to Graham's law. Already this law also we discussed, Graham's law of diffusion. Graham's law of diffusion is nothing but rate of diffusion is directly proportional to 1 by square root of density, and we can say this is rate of diffusion is inversely proportional to its square root of its density also we can say, R proportional to 1 by root D or R proportional to 1 by root M also. If you take for 2 different gases, then R1 by R2 equal to root M2 by M1. So, R1 by R2 equal to root M2 by M1. C option is correct. So, Graham's law will be C. So, this is the matching column 1 and column 2. We matched Boyle's law, P1 V1 equal to P2 V2. Charles' law, V proportional to T, V1 by V2 equal to T1 by T2. Dalton's law is E, P total pressure equal to sum of its partial pressures, and Graham's law of diffusion R1 by R2 equal to root of M2 by M1. Okay guys, so this is the matrix match type questions. Okay, let's see the next type of questions. Next we are going with integer type of questions. Okay, let's see integer type of questions. First one, 2 liters of a gas is collected at 273 degrees Celsius and 380 mm of Hg. The volumes at STP will be. So here two conditions, the given conditions and STP conditions we have to take. What are the given conditions? Let us see. The given volume is given 2 liters and collected at 273 degrees Celsius, means temperature is given 273 degrees Celsius and pressure is given P1 equal to 380 mm of Hg. Pressure is given and he is asking to calculate volume at STP. So compulsory we have to write down the STP conditions also here. The STP conditions, already we know what is STP, standard temperature and pressure. If you follow the previous video, then you will understand what is STP conditions, because in the previous video already we discussed about STP and different types of gases. Okay, see, STP means standard temperature and pressure conditions. Standard temperature, according to STP, the pressure will be 1 atmosphere and volume we have to find. Temperature will be 273 Kelvin. T2 will be 273 Kelvin. So P1 V1 T1, P2 V2 T2. But here see, here we have taken pressure in atmospheres. Here the pressure is given in mm of Hg. You have to maintain the same units. Either you have to convert into atmospheres or you have to convert atmospheres into mm of Hg. 1 atmosphere equal to 760 mm of Hg. Let's convert this P2 into 760 mm of Hg. Otherwise, you just convert this P1. Just divide with 760. Then you will get 1 by 2 atmospheres. Half atmospheres like we will get. So this is the condition. Okay, if you divide with 760, then mm of Hg will be converted into the atmospheres line. Now substitute the whole data into the given formula, that is P1 V1 by T1 equal to P2 V2 by T2. What we have to calculate V2? So I will take RHS side V2, then LHS P1 V1 T2 by P2 and T1. We know all the values, just substitute all those values here, then we will get the answer. P1 is 1 atmosphere, P1 is 1 by 2 atmosphere, it is P2, P1 is 1 by 2 atmospheres and V1 is 2 liters and T2 is 273 Kelvin by P2. P2 is 1 atmosphere and T1 is 273 degrees Celsius is given. This one we have to convert into the Kelvins, then 273 plus 273. Then it will be 546 Kelvin, right? So substitute here 546 Kelvin. Then see here 273 2 times 2 will get cancelled. So overall 1 by 2 is left, that is nothing but 0.5 liters, because we are finding V2. V2 is 0.5 liters. So the given question, 2 liters of a gas is collected at 273 degrees Celsius and 380 mm of Hg. The volume at STP will be 0.5 liters will be the volume. Okay, is it clear? Then we will go to the next problem. See, this is also analytical type, integer type question only. A gas diffuses 4 times as quickly as oxygen. The molecular weight of the gas is. See here, a gas diffuses 4 times as quickly as oxygen. The molecular weight of the gas is, here the rate of diffusion we have to take. Okay, so actually the formula R proportional to 1 by molecular weight, then R1 by R2 equal to root M2 by M1. So here two different rates is given, one of the gas is oxygen, another gas is molecular we have to take. So I will take first one as the oxygen and second one as the X. A gas X diffuses 4 times as quickly as oxygen. If RO2 will be R, then Rx gas will be 4R. Then MO2, oxygen's molecular weight is, for 1 oxygen it is 16, for 2 oxygens it is 32. Then what about Mx gas molecular weight we have to find. So simply substitute here. I will rewrite this formula for understanding. RO2 by Rx equal to MO2 by Rx equal to Mx by MO2. So what is rate of diffusion of oxygen? R by Rx is 4R, which is equal to Mx, we don't know, that is what we have to find, by MO2. Molecular weight of oxygen already we know, that is 32. Here RR will get cancelled, right? So to remove the square, I am taking, to remove the root, I am squaring on both sides. Then 1 by 4 whole square equal to Mx by 32, right? So therefore Mx equal to 32 by 4 square means 4 2s are 4 4s are 16, 16 2s are 32. So it is 2. What is the molecular weight of the gas is, that gas is 2. Okay, a gas diffuses 4 times as quickly as oxygen. The molecular weight of the gas is 2. Okay, this is also integer type question only. Let's see another type of questions. We completed integer type questions. Now we are going to analytical approach type of questions. Okay, let us see what is this analytical approach type questions. See the first question in analytical approach type. If the absolute temperature of a gas is doubled at constant pressure, then the volume of the gas will be. They said at constant pressure. Pressure is constant, then obviously the law is Charles' law, and the relation between volume and temperature is directly proportional to each other. Then if you take for two different types of gases, we can write this expression as V1 by T1 equal to V2 by T2. And now what is the data is given? See, if the absolute temperature of a gas is doubled at constant pressure, then the volume of the gas will be V1 equal to V, T1 equal to T. Then comes to V2, we have to find. When T2 is, the absolute temperature of a gas is doubled, means T becomes 2T. When temperature is doubled, then what about the volume? He is asking the relation. So simply this V1, T1, V2, T2 value substitute in the given formula. Then we will get V1 is V, T1 is T, V2 we have to find, T2 is 2T. Then TT will get cancelled, then V2 equal to 2V. So simply the volume is double, because both are inversely directly proportional to each other, right? Volume and temperature both are directly proportional to each other. If temperature is doubled, obviously volume also will be doubled, right? That is the theory type, and it is the expression type. Means we have done the calculation. According to that calculation, we can say volume is doubled if you double the temperature. So I will go with the options are given. Let's check here. First option is reduced to half. No, because both the volume and temperature according to Charles' law is directly proportional to each other. If it is reduced to half, means it indicates the inversely proportional, right? And also we got here 2V. 2V means it is doubled. So not the first option, and B option is doubled. Let's check the remaining options also. C option is reduced to 1/4. No reduction. There is only increasing. Increased to 8 times. No, it is not increased to 8 times. It is increased to 2 times only. So I will not go with D option. So the correct answer for this question is B, doubled. Okay guys, let's check the next one. A sample of nitrogen collected in the laboratory occupies a volume of 500 ml at a pressure of 1 atmosphere. What volume will the gas occupy at a pressure of 380 mm of Hg, assuming the temperature remains constant? Assuming the temperature remains constant like he given right here. Temperature remains constant. So let's find out what is the law applying here. Temperature is constant and he given the data 500 ml atmosphere, means he given the relation between pressure and volume and temperature. He given the temperature constant and given the relation for pressure and volume. So obviously we will use the formula P1 V1 equal to P2 V2. This is the formula we have to use for this problem. So from the given problem, let's check what is the data given. What is P1, what is V1, what we have to find P2 or V2. Let's check. A sample of nitrogen collected in the laboratory occupies volume 500 ml. So V1 is given 500 ml at a pressure of 1 atmosphere. So P1 is given for 1 atmosphere. When volume is 500 ml, then pressure is 1 atmosphere. What volume the gas occupy, means V2 he is asking to calculate at a pressure of 380 mm of Hg. So we have to find V2 from the given data. See here, while doing the problem, all the units must be in the same units, either CGS system or in MKS system. All the units should be in the same system. Here pressure is in atmospheres but P2 is given in 380 mm of Hg. So you want to convert, you have to convert even P2 into also atmosphere. So simply divide 380 into 760. In the previous problem we did the same. 760, then it will be 1/2 atmosphere. Now we have P1, P2, V1 also, we can find easily the V2. So substitute in this problem. P1 is 1 atmosphere, V1 is 500 ml, P2 is 1/2 into V2 we have to find. So simply 2 comes this side, then V2 value will be 500 into 2, 1000 ml. So our answer will be 1000 ml. Why did we take in mls? Because the 500 ml in the problem, volume is given in ml. So we will get the final volume also in ml, that is 1000 ml. First option is 250 ml, no. Second option is 500 ml, but we got 1000. C option is 750 ml, we got 1000. So I will go with the D option because that is 1000 ml. Okay. Let's go to the next question. The pressure of 8.40 liters of nitrogen gas in a flexible container is decreased to 1/2 of its original pressure and its absolute temperature is increased to double the original temperature. What is the new volume he is asking. So here pressure is changing, volume is changing and temperature is also, right. So let us see the relation for the combined gas loss, that is P1 V1 by T1 equal to P2 V2 by T2. Okay. Let's see the given data. The pressure of 8.40 liters of nitrogen gas in a flexible container is decreased to half of its original pressure. Suppose P1 equal to P. Then P2 became P by 2, half of its original pressure. And its absolute temperature T1 equal to T, and its absolute temperature is increased to double, means T2 became 2T. Then what about volume? Already volume is given here. How much they given? 8.40 liters. V1 is 8.40 liter. Then they are asking to find V2. Right? So this is the formula. This is the formula and this is the data. Just substitute in that, we will get the value of V2. So P1 is P, V1 is 8.40 by T1 value is T. Comes to P2, P2 is P by 2, we have to find V2 by T2 value is 2T, right. So simply we can get cancel PP, TT, this 2 comes to the denominator and will cross multiply, then V2 value will be 2 into 2, 4 into 8.40. Obviously 8 4s are 32, 8.40 means obviously roughly we can calculate the answer will be see 33.6 liters. See 8.40 you multiply just 16, 4 8s are 32, 1 33. So 33.6 liters will be the answer. V2 value is 33.6 liters. Okay, this is the conclusion. He asked to calculate the new volume. The new volume is 33.6 liters. Okay, let us see the next question. See here some graph is given. Let's see what is the graph. From the graph, the order of pressure of a gas is, from the graph, we have to take this graph. From this graph, what is the pressure order? P1, P2, P3. Let's see what is the graph is given. In one axis it is volume, on another axis it is temperature, right? And see here pressure is varying. Actually this is the graph we have to keep at temperature constant. If we keep temperature constant, when volume at V1 is here, V2 is here, V3 is here, when the volumes are increasing, volume is increasing, the pressure values will be decreases. See V1 is here, then P1 value will be here, V2 is here, see here, V1 is here, P1 is here, V2 value is increasing, then P2 is here, means pressure value is decreased, coming back. If V3 value is here, means V3 is increased, but P3 is here, means P3 values are decreasing. That is nothing but V1 is less than, V2 is less than V3. Absolutely it is the graph which is belongs to Boyle's law. Temperature we kept constant, then pressure is inversely proportional to its volume. So V1, V2, V3. Actually we know V1 is less than V2, less than V3. V1 suppose here it is 1, V2 will be 2, V3 will be 3. So V1 is less than, V2 is less than V3. So obviously pressure will be different. Means P1 is greater than, P2 is greater than P3. In this graph you can identify P1 is here. Suppose if you start 1, 2, 3, 4, 5, 6, 7, 8. P1 is 8 when V1 is 2. V2 is, when V1 is 1, P1 is 8. V2 is 2, then P2 is 6. V3 is 3, then P3 is 5. So both are inversely proportional to each other. V1 is less than, V2 is less than V3, then obviously P1 is greater than, P2 is greater than P3. P1 is 8, P2 is 6, P3 is 5. So the values are decreasing. So P1 is greater than, P2 is greater than P3. So check in the options First option is P1 is greater than P2 is greater than P3. It is less than is given wrong. No, it cannot be equal because both are inversely proportional to each other. Then P1 is less than P2, which is greater than P3. No. So we'll go with the first option. It is absolutely about the Boyle's law. Okay, let us see. So this is the behavior of gases total. In the behavior of gases, we have given 3 videos. In 3 videos, we have completed the behavior of gases. Okay, thank you so much. We'll come with the another chapter. Okay, thank you. Please watch the video.